Such as live webcasts, ladies and gentlemen. Hey, I'm Pete Meyer, technical editor for Motor Age Magazine, coming to you once more from the Car Clinic in Mahopac, New York, home of TST and G. Truglia. Thanks for joining us, G.
Hey, thank you, Pete.
Also very honored to have with us Dave Hobbs from Delphi, who's going to be co-presenting tonight on our fuel system diagnosis topic. And I'm proud to announce that Dave has also joined the contributing staff of Motor Age Magazine. If you haven't seen the November issue yet, look for Dave's debut garage feature. Very good feature he wrote for us indeed. Of course, tonight is sponsored by Delphi. I want to take a few minutes to say thank you to the folks at Delphi for making this possible, because they're picking up the tab. You guys don't have to, and it gives us the opportunity to provide you with just one other avenue to get the training and information that you need. Again, thanks so much for joining us. We appreciate you taking your time out, especially this close to the holidays. But just real quick, motorage.com will bring you to this landing page. There's lots of information for you online. If you like us in print, you're going to love what we're doing for you online. When you're up there, make sure you click the Join Community tab and join us in our online community, the Auto Pro Workshop. It's growing daily. We've got close to 3,000 members now on the community site.
Excellent.
Out of about half the people that come to visit us come again, looking for new information. So there's a lot of good stuff there. How To is our digital magazine. It's a sister publication. It's great for techs, students, teachers. A lot of great material in there. So by all means, take advantage of what we have to offer. It's there for you. And I think we'll move on to the next slide there.
Dave.
There we go. And now we're going to get ready to move into the meat of today's matter. Fuel system diagnosis from the tank to the injector. We're going to hang off on the PowerPoint for a moment. I'm going to step out of the way and let these guys take over.
Gee, thanks.
Gee, it's on you guys.
Okay.
And again, thanks for joining us. No further ado, Dave, G.
Hey, thank you. I want to thank TST, and especially Car Clinic. Craig Truglia, Alex is here, one of the lead techs here at the shop. This is a working shop, folks, so we have real broken cars, real problems to talk about, and there's going to be something for every level of technician out there. If you're entry level, you know, just getting your feet wet, or you're an ace, you've been doing this for decades, learn something new tonight.
But you always learn something new, even
Exactly.
if you are an ace, right?
Well, you forget things.
We're old aces, and always
right.
look for the king or queen coming in. But anyway, you know, this is live, as we said, and as we're going through tonight, sometimes things don't always work as intended, but we're going to show you real live stuff, and I guess we'll start with fuel systems first, right?
Over here's our simulators.
So let's go over first and talk about injectors. Okay. We have a flow injector tested here, but all we is used to looking at a regular fuel injector. And how do you know the fuel injector is good or bad? Well, we're going to show you some tests that you need to know. We could do hydrocarbons per cylinder, correct?
Right.
Many of the scan tools you're using are cutting cylinders out one at a time. When you cut a cylinder out one at a time, if we can do a hydrocarbon per cylinder test or O2 per cylinder test, we can see what's going on. It's better, by the way, if you do it pre-cat, because a lot of the catalytic converters nowadays are pretty damn good to clean up all of those hydrocarbons. Now you may ask, well, how do we do this pre-cat? Well, we can do this many ways. One way is if you're working on a Ford with a DPFE, that's the differential back pressure sensor, you can make up a little thing that's a little connection between your gas analyzer and that connection, and put your hose in there and get a reading. Toyota, Mitsubishi, Chrysler, okay, there's many car companies that use differential back pressure. If that's not available, let me explain this. We're not looking for fuel control when you want to see cutting out a cylinder if it affects it, right?
So you could go in through the O2 sensor.
Very good. We can go into the O2 sensor, or we can use something like BG and WINS make these great EGR plates. Take the EGR valve off. You can put this little plate on there with a little adapter. There's another way to get pre-cat. Never ever tap in and drill holes into an exhaust.
Well, there are all kits out there that do that, right?
There are, but with stainless steel pipes costing big money and pre-cats, that is expensive. You know, if the car has 150,000 miles on it, there's no other way to get in there. Yeah, we know the real world people would do that. You know, we showed you there's a great gas analyzer we have here. EMS, Craig, is it?
Yeah.
And they have the best kit I've ever seen for doing it, where it screws in, taps, and has a nice screw. But that would only be used in last resort. Okay, so we don't really like, at least I don't, I know in the state of New York that we're in, that is a non-quality repair, meaning no one from the Department of Motor Vehicle would allow you to drill into someone's pipe and put that hole in there, because we could have exhaust gases coming out later. We could have tons of problems, maybe something melting or whatever. So let's not try to do that. So anyway, we're going to be talking about injectors first. Now,
A question for you.
Sure.
I run into a lot of technicians in places not like New York, like the Midwest and South, where there are no emissions testing.
Right.
So they don't have the engine analyzer working anymore. They don't have the gas analyzer working. They haven't used it in years. So I talk to them about gas, they look at me like I'm from Mars.
I know the feeling.
So what's a tech going to do in those cases?
Well, then he's going to do something like we're going to try here. He needs to see what the flow rate is by checking the injectors. We have hooked up here, this is a launch tester, we'll show you flow here in a second. But here's something that you could buy quite reasonable from OTC. It's something that every technician should really have. And I made a couple of jumper wires here for a couple of reasons. One, to connect this in. Two, if you wanted to do current ramping on that injector. But we're going to plug this in. And the first thing we're going to do is a very simple test. The simple test is to take our digital voltometer, whatever brand we could use, Fluke or UEI here. I'm going to use the UEI. We're going to go negative, positive, and Dave is very steady. He's a good Vanna White over here, I can tell you that. And what I'm going to do is go to ohms. And the resistance should come up if I have a connection. But of course, you need a connection.
How about here?
That won't matter.
Your voice. Oh, there we go.
One more, look at that. Okay, so we probably got about, there we go,
12 ohms.
12 ohms. So now, if you look in the little book, I noticed by heart, in the little book, the higher the resistance, we switch the amperage, we go to 0.5. There's a book that tells you when you go to 4, this would be like on a throttle body injector. Resistance would be half an ohm, be very, very low. Low resistance, high amperage. Now, once we do that, there's something here called a coil test. On a coil test, we switch our meter to DC volts. When I press this button, it automatically will test this injector. We're looking for somewhere about 9 volts to 6 volts, somewhere in that range. If it falls under that, then you would have a problem. Now you do this for each injector, and there's a mathematical equation, pretty easy. Subtract some stuff, see what the average is. One that's too low or too high is a bad injector.
So we're checking the injector's electrical integrity right now.
Right, for the coil.
Right.
We know with the ohm meter, or use a power probe, we can see that was 12 ohms. We then place it on the half ohm. We press the button, and you can see it goes down to about 6 volts. Okay, so we got 6 volts, 100 and something volts. It goes off. We have no more voltage on the meter. Let's do that one more time. As soon as you get the green ready light, can't do it until the light comes on. Okay, light comes on, watch the meter. Okay, let go of the button. 6 volts, 179 or so millivolts. So that's telling us what this injector's doing on the coil side. Usually 6 volts on and half an ohm, half an amp injector is good. Now, that's one test you can do. The next test you would do, and you would do this for each injector. Okay, now if you don't have this particular piece of equipment, what you're doing is really not testing injectors properly. We're going to leave that connected. Now, I'm just going to pressurize this a little bit. There should be some stuff in there. Okay, now, you notice, I want you to see if you can zone in on this, that basically everything is running except this cylinder here. Right? You see the spray?
You just move
Now,
move off to one side there, G.
oop, one more
There you
time. Yeah, Dave, you can hit it. Okay, hit the stop button. So they're all running but one.
3 out of 4.
Okay, now with this tester, you would hook a fuel pressure gauge up. We're going to use a random number of 50 pounds of pressure, right? Well, what you're going to do is on each injector, you're going to switch this over now to the balance test. The balance test is going to be, when you hit this button, is a predetermined amount of time that that injector would spray fuel. Okay? Now you're going to look for the pressure gauge to drop. Let's say one drops to 40. Another one drops to 39. Another one drops to 46.
You're going to do this with the key on engine stopped.
Right.
And
Twice.
every time you'll have to turn the key off, wait 15 seconds for that computer to go to sleep, turn the key back on, get your 2-second prime pulse so you can get a good pressurization of the rail to get an accurate test on each injector.
Now Dave brings something very important up there. In other words, we need to start with that 50 pounds all the time. So you
Yeah.
need to pressurize, depressurize. In between cylinders, when you're doing this, you never ever want to cause hydrostatic lock. So what I like doing, once I'm done with one cylinder, I like just starting the car up just for safety reasons.
It'd not be a bad idea to change the oil too.
If you really overpress it, twice probably wouldn't kill you. By the way, a good thing to do when we talk about oil is do the dipstick burn test. If you think that the oil has been contaminated, take the dipstick out. Don't do this around any flammable products like in your shop. Go outside, use a lighter under it. If this thing starts cooking, get the marshmallows out. And I'm only kidding, that's tomorrow, that's Thursday, Thanksgiving, okay? No, what you do then is you need to change the oil in the filter. But that, usually with this test, that's not a problem. So now, what we're gonna do, since the rail is pressurized, we're gonna hit this button once. We're gonna go run test in progress, and you see the fuel spraying out. Now what that does, that's where the pressure gauge would drop down. So I'm just going to power this up again, get some pressure in the rail. We're going to make sure this light comes back on again. That'd be like turning the key on, pressure coming up to 50 pounds. We got the ready test. Look at number 4 only. You can see it's spraying. The pressure gauge would drop down. When the pressure gauge drops down, you need to record that. And here's an example. 50 pounds is our starting. So let's say we're 40 on one, 40 on another one. They're equal, right? But how about if one has 20 and the other one has 48? The one with 20 has a major leak, doesn't it? Has a drip, something wrong with the pintle and whatever. We'll get to that question in 1 second. And by the way, ask all the questions. We got plenty of time. This is Motor Age and TST here, so with our buddies from Delphi, we could stay on just about forever. I don't have to go home to Thanksgiving. He has to go home, but not me. So if you see one is too high, you could have a clogged screen in the injector. And this is quite common. And when we talk about that, if you think that that is not the case, and we'll look at this a little later, I don't know if you can zoom in on this injector. If you need me to come closer, look at the debris, the rust on this injector. You see it? Now that happens when the tank flakes, all the rust comes up, fuel filter not changed, sometimes even particles of paper. And we'll talk about that later, about wetting something. Okay? That'll be wetting the filter. Now let's take some questions. So we just went over a whole bunch of stuff there.
We'll run back to PowerPoint. I've got a slide on rusty injectors.
We could do that. Why don't you click over there and then we'll go over and look at that.
What engine temperature, let me say it louder for the microphone. At what engine temperature should these amperage tests be conducted?
Okay. Now that's where your RTFB, read the freaking book, because there is a difference between a cold injector and a hot injector.
And usually there's a spec for both cold and hot that gives a temperature.
Right. It's going to be a little different. Now, if you're going to test it when it's failing, it's probably a good idea to check it when it's warm. If you want to do them both cold and warm, that's up to you. I would say do this on a warm engine. Now that's when resistance changes of the injector, and that's when you may get a different drop in pressure.
If you're intermittent, do it during the temperature that the intermittent problem is reported to occur. I had a 4-cylinder years ago that only misfired on one cylinder when it was extremely cold. And so that's when we caught that injector actually dropping down to a low resistance Normally they drop down when they get hot, right, G?
Yeah.
But this one, when it got cold, it dropped down from 2 ohms to 1 ohm, and it wouldn't fire.
You know, hang on a second. I want to show you a great tool while Pete is going to say something here. I want to show you a great tool for checking that.
So I can go ahead and go to that,
Well, I'll be on real
that
quick.
PowerPoint slide if you want.
While we're checking some of these patterns or information that G and Dave have given you so far, I just want to throw in my own little 2 cents here. If you're checking the resistance or concerned about the resistance on the injector windings, another great way, and I'm sure we're going to show you a little bit later on, is use your low current amp clamp to check the series all at one time. You can check all 4, 6, or 8 injectors at one shot, and if you got one that's got a resistance issue, it's going to show up. It's going to stand out from the rest. And I'm another kind of, I like my scope. If I can find a way to cheat and use my scope, there's another
It's
thing
always a
that you
good
can
way.
do.
Checking pintle openings on some, checking amperage draw. You know, amperage is easy since you have 2 wires go around one of the 2 wires. And be careful, a lot of guys, when I'm doing a class, try to go around sheathing, the plastic sheathing. You will not get a good picture like that. Make sure the jaws are closed on the amp clamp, go around one of them, and then what you can do is basically, what is that buzzing? Basically pick up, it's annoying buzzing, sorry about that. Basically pick up the difference between each injector, especially if you overlay.
Yeah.
Yeah,
Very, very important.
I'm gonna grab an injector real quick.
And what I was saying too, the other thing you can check for injector balance is you can use a pressure transducer on your scope. Plug it right in the fuel rail. Pico makes one, the WPS 500. Fluke has the PV series, and First Look has the one for the rail. And all of those can help you do these things in
Sure.
a pretty
And
quick
these
manner.
are, you know, these are great. The Bernie Thompson one's great.
Yep.
Any pressure transducer, I have the old Fluke PV besides the Bernie ones, they work great.
Yeah.
And not only could we use it, I gotta disconnect this before it drives me wacky.
Oh, that's your box.
That's my power probe, giving me power probe noise. So see, I wasn't going crazy. Anyway, hot and cold. I don't know if you guys have this. Yes, we're getting a flashback in time, and no, I'm not back in '69. I do remember those days just a itsy bit. But anyway,
Choke test.
a choke tester. You know what this thing does? It's cold on one end, hot on the other end. We talked about heating the injector up or cooling the injector. I don't know what in the world is buzzing.
So shop air.
Shop air goes
Got
for
a
that.
Venturi in here. Shop air causes this air to go a high pressure out one side, a lower pressure out the other side. And you know when you drop pressure, you drop temperature.
Right.
So I used those, I can't tell you how long ago.
Yeah, and I use this
They
all
were
the
very
time.
effective. I never thought about getting it out again on an injector, but that's a great idea.
In fact, when I'm doing my engine and emission class, I tell guys to buy this. You can go on eBay. There's some people that, you know, get rid of them pretty cheap. Why? Because we can do the old screwdriver test, use the handle, tap a component, whether it be a map sensor, mass air,
Right.
you know, a crank sensor. I've had crank sensors fail when they're hot. I've had them fail when they're cold. So it's a great thing to use, a great tool, a choke tester. So if you see them out there, pick them up. This one's from Mac Tools, but I'm sure they don't sell it anymore. But I'm sure you can find it. Let me put this down and let's move on. The little screens that are in here, this gives you a real good idea if you could zoom in. Right inside there is a little basket. And if you want to see what these screens look like, you can get a pick and pick them out. Okay, we happen to have some screens here. Are we looking good, gentlemen?
Yeah, I get
Okay, now let me get the Vanna White hands out of the way. Let's look in the bottom here.
Uh-oh.
This is looks like a Jim Linder supply of injector parts here.
Well, we got enough stuff here, but trying to find the screens.
You know, the bottom line is they are serviceable, the screens, that's what the tech was asking, right? That you can find them, maybe not every car store is gonna have them.
Well,
You have to order them in bulk
Here's some big screens
for the TBI.
for TBI, just to give you an idea. The other basket ones are very, very small, and maybe while Dave is doing the Vanna White stuff there, I maybe can find a small one here. And I've seen them today as well.
I can see it's cone-shaped plastic, and it's gonna be a really small pick with a 90-degree tip on the end of it. to pull that out. It's not going to be an easy job, but compared to the price of an injector. Also, while he's looking, we can switch over to the PowerPoint. I got a picture on the screen
Got it.
of an injector with rust. You don't really notice it until you pull the injector out and inspect it thoroughly. So a lot of techs may be tempted, hey, I've got an injector, I did the flow test like G was demonstrating, and it didn't pass, so I'm going to put an injector in, maybe opt for a set of injectors in the car, and you don't look at that screen, you don't catch the rust and stuff in there. All that's going to happen is you're going to meet that customer named Sam Ting. You know that guy? He comes back and says, my car is doing the Sam Ting again. You don't want him coming back to your shop. You want it to be fixed once and for all. So if you got contamination issues in the rail, contamination issues with maybe metal lines that have got rust on the inside, you're going to have to take care of that. How do you know you've got that problem? You look at that injector.
So I found this is the one that goes into a conventional, let me see if I can lay it down on my hand.
Very small. But that's a serviceable item.
That's a serviceable
Where would you
item.
find it?
This, you can buy these screens, and by the way, the company behind us, Launch, is selling one of these units here for a very reasonable price, okay, that you could start servicing injectors, and I say reasonable, $2,000, $2,100 or so,
Really?
to get this flow bench behind us. It also comes with an ultrasonic cleaner that you could clean the injectors with the basket out, then put these in. And to give you an idea of what that screen, the difference of the screen, look at all the rust on the screen compared to,
Nice, clean, new one. Wow.
can you see the difference?
That
You
fuel
say-
system had some real
You
problems.
say fuel economy.
Yeah.
That's one way to get more miles per gallon.
Well, actually, wouldn't you result in the trims shifting
Yeah.
to make up for that?
That'd be some high trims, I'm thinking.
But how do
Definitely be
you-
a trim problem.
How do you pop those out and put a new one in? Like, what tools do you use and stuff?
A pick.
Oh, okay.
A pick could easily take this out, or you can use a little screw. Sometimes you can screw down in here, just like, the slide hammer type things. You screw down, but usually a little screw can come right down and just pop them out. But a pick gets them out most of the time. Put a new one in, you can just find something of the same circumference to press them down in, lube them up a little bit, and they should go right into the injector. So not a major deal. Now, by the way, talking about fuel injection cleaning, when you look at fuel injection cleaning, I'm sorry to bend down on you here. When you talk about fuel injection cleaning, if you got rust buildup in there, that is plenty of great products. Run Right is the Chevron Techron stuff that works real good. Wins, BG is phenomenal stuff I used for years, as well as the Run Right stuff. Well, guess what? You cannot clean that rust out of there. There's no way that you're going to clean this. And I know what you're thinking. I have a Motivac, great tool. Motivac is phenomenal. The only one that'll really flush the rail out. When do you get your rail? And we'll talk about that. It's the only one that really will flush the rail out. So what that means is when I come in on a Motivac system, it's going to come through here and keep circulating and pulsing the rail, agitating it, sort of like a wash machine
Right.
for fuel rails. And if there's something that's cleanable in there, then yes, that can help clean it out. But if when you're packed with rust, I had some injectors, the whole top when I took them out, this whole part where the screen is up here, totally packed. There's no way you're cleaning it out.
Gee, if you don't have the motor vac, but you do have, let's say, pressurized, let's say a BG cleaner or something
Not gonna
like
do
that,
it.
you recommend taking the rail off
Out.
then, and
And
the
then-
injectors out, and then really getting through there, because you'll get the sediment buildup, is that right?
That's correct.
The back
If
end?
you take this rail out, like Dave said, and you have a BG, a Wins, or a Run Right, we could screw it on here. Again, has to be in a safe container, low pressure at first. Clean the rail out, make sure it's coming out one at a time from here, and just put them back in when you're done, okay? The injector itself, you're gonna have to look at the screen.
Yeah.
Another way to do it, with our tester, we could pulse each injector, couldn't we? Just like I did back here. We could pulse every injector while we have it pressurized to see
With the rail
if-
jacked up.
with the rail jacked up if we're spraying out. By the way, make sure you put it into a suitable container, okay?
Just don't spray it on top of the engine.
Not a good idea. No smoking, no spraying on the engine, hot manifolds or anything. The other thing is the drip test. You know what the drip test is? Let's get some shop rags under this when we have the rail pressurized. Do we have any of them leaking or dripping? Very common problem, by the way.
Right.
Because what happens under here, and these are cap tips, what happens, we start getting buildup, the valve or the solenoid won't close all the way because of carbon deposits, okay? And then it drips, and that's how we get more carbon buildup in the engine. So again, something like a BG or a Run Right works real well. So that's something to test. So again, just to review, how do we test it? With the rail out, we can pressurize the system. We can clean the rail out by what? Taking one injector at a time, see if that port clears out. Put it back in, clean the next one. And always use new O-rings.
Yes.
Very important.
Yeah, with direct injection, a must. You're not going to put that injector back in there,
By the way,
without using a new O-ring.
Never ever put your hands in the way of any fuel or high pressure. This will be like an immunization shot where basically that fuel will go right in through your skin into your bloodstream, and then it'll be too late.
Yeah, instead of penicillin, it'll be blood poisoning. Nothing's going to
Unleaded or super? Which one do you want to go by?
I think I want to live to see Thanksgiving.
But anyway, that's how you do it. And you test after cleaning the rail, and we'll get to the question in 1 second. You then would spray the injector by pressing that button. If you get a clean, clear pattern in a suitable container, even if you want to measure it then you can tell each injector is working good. Now that's, by the way, in extreme cases, right?
Right.
Because if we do the hydrocarbons per cylinder, we do a power balance test. Remember, we can get P0 301 to 308
Yep.
through whatever vehicle we're working on. We can get random misfire, all because of an injector problem. It could also be a voltage drop problem. Pete and I did a VD voltage drop thing a while back. A lot of these have rubbers missing. A lot of them have poor connections. So it could be an electrical problem causing that as well. So don't leave any stone unturned. Question time.
Can you reverse flush an injector or even reduce flush pressures as to not cause damage?
Yes, we've done it all. We've seen some that were really messed up and we reverse flushed it. It does work in many cases where they're pretty packed up. We also found that sometimes it's going to take overnight in the cleaning solution and the ultrasound, not an hour or two, sometimes overnight and then some, right? We've had some that took a while, but when we start flowing them like we're going to do here in a second, it really worked quite well. And I'll just get this prepared while you have more questions there.
Now, besides your misfire codes with an injector that's not flowing, which you could catch with the pressure drop test, you could also catch with an apparatus like the launch here, actually seeing the flow. How about an injector that you mentioned doesn't turn off? What would the symptom be? Would it be rich black smoke on a startup? And then when you put your gauge on, when you did that pressure drop test, it's just going to keep dropping. You turn the key off, you're done. It goes from 45, whatever, to 30, and just rapidly. That would be the time to jack that rail up and see which one of those injectors is dripping. Because you really don't know from the pressure drop test if the injector is dripping. You just know it flowed enough, or it did the same amount of pressure drop as the other injectors. But when you pull that rail up, then you can see which injector is still dripping.
Correct. Another thing to do is take a spark plug out sometimes, a long screwdriver with a rubber hose. Put the rubber hose at the end of the screwdriver. This is if you don't have the right equipment. And again, right equipment makes life easier. We're not here to sell you equipment, but we're here to tell you how to do the test. So take the plug out, put the screwdriver in there, put the rubber tip on that screwdriver first, and if you see the hose come out wet, you got the drips from the injector. Works quite well.
Great idea.
By the way, borescope, video scope, whatever, really neat stuff. Again, tools make life a lot easier.
A few quick questions.
Sure.
How often should you clean injectors?
Well, I'd recommend, and what I do on my own car about every 6,000 miles, put some Chevron Techron in the tank. That cleans the whole fuel system up. Cleaning an injector, probably good to get your customers on a maintenance schedule about 30,000 miles. Now, in 30,000 miles, a lot of these cars, and we won't talk about direct injection just yet, a lot of these cars start building carbon buildup. Years back, I did a bunch of testing with a gas company, we can't mention the name, but we've seen people using the wrong fuel, super unleaded, in a car that uses regular unleaded. Okay? What happens? The molecules of fuel take more heat energy to dissipate or burn. Therefore, more carbon builds up.
Right.
In short as 3,000 to 7,000 miles, you can get carbon buildup where you would need to clean it. Okay? Or prolonged idling. It depends quality of fuel you're buying. So I'd say 30,000 miles is a good way, and we talk injector cleaning. Shut the fuel pump off, number one, after the car's warmed up. The procedure should be car warmed up, find out what the fuel pressure spec is, block off the return line. Blocking off the return line, not using vice grips or anything else. There's a lot of rubber hoses that have a plastic type insert in them. You clamp it and you just crimp that
So
hose.
it's not just the plastic pipes that we obviously know not to clamp with, even with clamp-off pliers.
Right.
Let alone vice grips. But even with regular clamp-off pliers that are designed to do that, it may not be neoprene all the way through.
You got it. It's not. In many cases nowadays, it's not. So what do you need to do? Similar to the hookup we have here, we disconnected the hose. You would have to run a rubber hose in between this connection where you can crimp off. Okay? Now we do that on some of the flow gauges. We run it in series with it so we can kind of get a crimp. That way you can deadhead the pump. When we deadhead a pump, we crimp off and we should have a minimal of double the pressure, right? On most vehicles except the Vortex vehicles.
With the
Vortex,
sequential central port.
sequential injections, the mechanical injectors,
Spiders.
they're already running at 60 PSI. That pump is going to maybe give you 10 PSI more. Right. Just like when you're dealing with the vacuum on the pressure regulator drop, right? Same setup. Questions? Because we set them out for.
How effective is it to go through a vacuum port to do an injection cleaning service?
Well, that's not an injection cleaning service. That's a very good question. That is a decarbonization, meaning what you're doing is sucking in through a major vacuum port. And some cars, by the way, are not using the complete manifold. They may be using 1 to 2 cylinders, like some of the European cars. And what you're doing is you're sucking this cleaner in through the brake booster that you think is going to the whole engine, and only 1 or 2 of the cylinders are actually getting cleaned.
An imbalance may be worse than the
Before.
problem you had before.
I would suggest a better way, something like Run Right has, or BG again. They have these little devices that go in behind the boot on a mass airflow sensor type car, and it sprays in a fine mist that helps go through the system to clean airflow and fuel as it's going in. Now, direct injection, that's a different ballgame. Okay? And by the way, direct injection, many problems now, from GM vehicles to Volkswagen, Audi, BMW, Mercedes, Volvo, to all having carbon buildup big time.
You think about it, what's there to wash the valve? The injector is not going to wash the valve off. So if you have Tectron, you have the top tier gasoline
Yes,
that those manufacturers you mentioned, a lot of them are requiring, it's not going to do any good. That valve is going to get the carbon from blow-by gases from the crankcase and things like that. Nothing to clean it off because the injector is directly in the cylinder.
Right. Similar to a diesel. You know, one of the things I like doing in a fuel class is when you shut the vehicle off, you know how many hydrocarbon vapors are floating around? I always say, no pun intended here, but play a doctor for the day. Put a rag, because protect your hand, shut the vehicle off and do a swipe in the intake. And all that black, sooty stuff that you pull out, when you look in with a video scope with the motor off inside the intake, it looks like it's Christmas time, it's snowing. There's all these hydrocarbon vapors floating around. And what happens, they're floating around, the engine's hot, it starts coking and sticking to the whole intake system and the valves and so on. That's why you need some of these cleanings. Now, word of caution, when we clean cars with electronic throttle like this for the intake, oh boy, you got some problem there because we said you went in through the intake. You get chemical on any of those computer boards for electronic throttle, you're out about 3 bills. That's a hay of a lot of money, right?
Yep.
So we don't want you to spend a lot of money. You need to be wise when you use it, know where to spray it, and not have an issue, okay? Also, sometimes if you spray it, like on Nissans, Infinitis, Volkswagens, Audis, they're finicky with electronic throttle. Does your scan tool have the right procedure in case the car stalls out to reset the adaptive idle? If it doesn't have it, you're in trouble, so it's time to look at your OTC, your Snap-on, your Joe Schmo brand tool. Got the factory tool, there's not a problem, or something like maybe Launch or, you know, some Auto X-Ray type stuff, and some of the other big players have it OTC and Snap-on, sometimes. Check it out, very important. Questions, Craig?
Last quick question, and please repeat the questions.
I will.
What do you lubricate the O-rings on a fuel injector? Like, what do you use to lubricate it?
You can use a little Vaseline, if you have Vaseline around. Oh, what do you use to lubricate the O-rings on the fuel injector? You could use fuel. I would not recommend using like carburetor cleaner or a throttle cleaner. You don't know what would happen between that and the direct gaskets that they're using.
Right.
You could always use a little Vaseline, you know, when you were packing the pumps years back, the oil pumps. Little Vaseline is not going to hurt anything. We're not talking about a whole bunch. Put a little bit on your finger, give it a little swipe. It goes right in, not an issue.
Silicone wouldn't be a good idea because the O2 sensor, about a little motor oil.
Motor oil could help. You know, the dipstick's right there. You can take it out. You always have a little oil there. That could help as well. It's a hydrocarbon. Again, I prefer not to use, you know, anything but the gas, the oil, and or the Vaseline, just in case. You know, I'm a
Petroleum
little
product.
wary of what would seal or not seal.
Yeah.
Remember the old days of the Volkswagens with the mechanical injectors? The seals used to go bad in the back all the time. You take a propane bottle with the long wand and you would see if the engine was running bad. As soon as you went near an injector seal, the baby would, you know, smooth out. Otherwise it'd be, and this is one way. You can look at the O2 sensor when you were doing that.
Yep.
So these are some little tips that you can still use today, okay, by looking at your O2 on a scan tool or a lab scope and using a propane bottle that you should all have. Pete?
Yeah, just want to point out for some of the people watching that a lot of the questions that these guys are answering or asking, the information is in your service information system. Always look through the procedure before you begin the
Right.
procedure.
Right. Now, so what Pete said, in case you couldn't hear him, is, you know, all the questions you guys are asking, and good questions, thank you very much, is look in All Data or Mitchell or factory information. A lot of the things are right in the procedure, especially All Data. All Data has that little sidebar, like, you know, tells you about the system, little step-by-step what to
Right,
do,
right.
and factory information as well. And by the way, let's not forget Identifix, and I'm sure you've seen this, Pete. Identifix now has factory info that is up there, so pretty impressive. If you don't have Identifix, check that out. Not a commercial firm, but we're here to give you helpful tools to help you diagnose and fix the car. Okay, Craig, more questions?
No, it's good for now.
Okay, so now, since I'm almost out of a New York minute here, we're going to look, I'm going to do a test here, an ejector flow test, and you would only do this if you found the hydrocarbons per cylinder to be off. The balance test, remember we said the 50 pounds and so on? The balance test was not good, right? We had one go to 40, another one's 40, one stays out at 48, and one goes down to 20. We would need to take them out and do something like that. And hit the button. It pressurizes, and here we go. First of all, what to look for, the conical padding. Okay, you like nice spray, no drips. We can see we got a little difference. At least this one looks different than the other ones. They're all connected the same. Okay. The other thing to look at, some injectors spray to the side, right? Angle injectors. You need to know what type of injector you're dealing
Some
with.
may spray two-side
Two-side.
for a multi-cam engine. And
Right.
you got to make sure you index
Indexing.
those into the
And
manifold.
how about our multi-tip injectors nowadays? Not all the pintle, as we were seeing before, meaning, you know, I have one little hole on the bottom, but we have multiple holes or plates on the bottom.
Right.
Okay? So now, once we do this test, we look to see if they're all about even. and one looks like it's sprayed itsy bit more, but that's good enough. If we had one up here and one was down there, then we would have to ultrasonically clean them. Now again, you got a car running bad. Okay, I remember a Ford van years back that a guy in this complex here, a construction guy, bought a bunch of brand new Ford vans. And at that time, I didn't have this machine. I had to send them out to our buddy Jim Lender, who used to do injectors. And basically, from using this test, I found, and the hydrocarbon persona test, I found a couple of injectors to be off, and I tagged them. Okay? And I said to Dougie, who worked there at the time, I said, Doug, I got them all tagged. I want you to check these injectors and let me know. I'm not going to tell you which ones are bad. I want you to tell me if you find any of them bad. Well, sure as hay, he had to change 3 of them. 3 of them were flowing totally different than the rest of them. When he got it back, the engine from running like this new, didn't set a code, but it was running lousy. When it came back, this thing was very, very smooth. So it's something that, again, that's why we're going to do it. We may have a customer complaint, a drivability issue, maybe a little bit than normal, higher emissions. Okay. We're going to show you another quick test while we're playing with injectors here. And this one we're going to use our power probe. Okay, so now we have an injector somewhere here. Sure, I have one here somewhere. Okay. I had one all set up, but I don't see it. Oh well, we're going to use this injector. Here's what I'm going to do. We're going to take our power probe, and here's always an easy test to do. I had one set up, but again, not here. First thing to do with our power probe is we're going to connect it to make sure we got continuity. You see the green light came on. Okay. The other thing is when we're connected to a car battery, there's an 8 amp breaker in here. You want to make sure you got a good ground. You hit the button. You hear how that popped? Now I have no more power. See that? No more power. The 8 amp breaker came out. Why do you want to do that? You want to make sure you got good power and ground before we start. Everyone okay with that? I'm going to reset it. Now I'm going to have power. Red light on. Ground. Going to take one end, the ground lead. Our injector has 2 sides. Now be careful, some things have diodes in them nowadays. We know this doesn't. We can easily check that with our meter.
Right.
Okay? And we did beforehand. It's an older injector. I'm going to one side of the injector. I'm going to take the probe. I'm going to touch the other side. If I have continuity, I should have a green light. I got a green light, right? Now I'm going to ask Dave to put the amp clamp on to amps DC. Go around this black wire. He's going to zero it. He's going to go around the wire of the power probe right here. Okay. And I'm going to hit the button, and we're going to test it. I would say this has about 600-700 milliamps, because there's no pressure. Are we ready?
Ready. Can you get that?
Yeah.
That angle?
That's
Got
good.
it?
That's good.
How much? I can't see.
740 million.
740. No pressure behind it. Now this is another good test. What you're doing here is you're testing this injector for current, which is important.
Right.
Now, if you think about when you do this on a bench or on the car, when you're doing amperage, you're seeing if there's any work being done. Okay? If the amperage is low, we may have a clogged screen. Right?
Right, right.
If the amperage is high, we could have, on all the injectors, we could have crazy fuel pressure, right? The pressure could be very high. If the amperage is high,
Or
just
low
on one.
resistance in the winding.
Very
But
good.
you're saying that the winding checks out good on resistance, but yet the actual current draw is way low. The fuel pressure may be way low because it's not doing its work.
And that would be on every injector, correct?
And it takes some resistance, some muscle to pull up against that pressure
That's right.
to spray past the pencil.
But we would be looking at that, just remove that. We'd be looking at that on every single injector. So if our pressure is low on our amperage low on every injector, the pressure could be low. If the amperage is high on every injector, the pressure could be high. They have
Considering,
regulated.
like on this Ford, we had to break into the fuel system Alex had to get all these adapters out
Thank
to
God
get that
for
fuel,
Alex.
yeah, fuel pressure.
Us old guys forget.
Fuel pressure hooked up. This would be a quick and dirty way with an amp clamp to see what's going on with pressure, give you a ballpark idea. Do I need to get that fuel pressure test kit out
Right.
and intrude into the system, or does everything look kosher with the injector current? Never
Right.
thought of it before. You're a real MacGyver, you know it, Gene?
Well, you know, playing with this stuff, you kind of figure stuff out, right? Now, if the other thing is if amperage is high on only one injector, well, you know the Pintaloo is a ballpoint pen here. Pete, in your pocket, ballpoint pen. Injector is basically doing this, right? See the clicking on and off, it does it in milliseconds. 1,000 milliseconds makes 1 second, right?
Right.
So about 4 milliseconds, the average, 250 times a second, that injector's going up and down at idle, right?
Right.
Now, let's say this had a problem in here where the pintle is bent. The windings are perfect.
Right?
Where's amperage gonna go?
Gotta go up.
And once it passes 1.2 amps, that's when you're gonna burn the driver out. Some drivers, if you remember the old quad driver, that brings me back to the
Yeah.
quad 4 motor.
Yeah.
Better said, do a sign of the cross here for that. The quad 4, well, I used to go cha-ching actually back then. But anyway, you knew that code 26 would come up.
Yeah, code 26.
They had more type of injector problems or solenoid problems
Right.
than you can shake a stick at. So you can also test it for that, okay? Now, we're pretty much done with injectors, and the other thing we have over here, Dave, once I kick my wires out of the way, is we have the pico scope hooked up in this case. Okay, so now we got a flow board here. Don't worry about the noise in the background on the scope. We're not worried about that right now. I have a fuel pump in here, and I'm going to switch a couple of fuel pumps. Inside here, I don't know if you can look in, we have a fuel pump in lamp oil. Pretty tough to tell, but in here is a fuel pump. I'll pick it up in a second. Let me move that over there, get that out of the way, get some gloves on. So we're going to run this. This is our pressure gauge, and my point here is pressure and volume, and this is a volume gauge. So we have our pump hooked up with an amp clamp on the pico scope. I have our lab scope on the red channel, channel 2, on AC voltage. How many times has your amp clamp failed or broke? It happens, right? Slam the hood on it, something happens. So I want to show you something that maybe you can do current with your meter and a 10 amp fuse to see what the amperage is, but how do you know the pattern's good or bad? So here's what we're going to do. We're going to run this pump. This is a pump at about 48 pounds. We have over 6/10 of a gallon of flow. 6/10 of a gallon of flow is quite good. Okay, so 6/10 of a gallon. That is very, very good. Our pressure is 50 something. Now, look at our amperage. The amp clamp is in blue. Let me get my big head out of the way. Amp clamp is in blue. AC voltage is in red. And you heard me right. That's AC voltage. Watch. I take one of the wires off. You see it just do nothing, and the wire's in my hand. Okay? I put the wire back. So you can go across your pump or the relay, okay? And what you're looking at is, this is going to mimic.
So you're just
The
looking
amp
at the
clamp.
closed circuit voltage, like you were back probing the fuel pump.
The fuel pump, correct.
With the voltmeter, or in this case, with the lab scope.
With the lab
on
scope.
voltage. So voltage is in red.
And amperage is in blue.
It makes sense. Ohm's law. They're
Yep.
connected. So it's
And look at this.
MacGyver's amp clamp.
Now, if we did our meter in series, okay, we could see what the amperage is. Let's say, okay, this pump's supposed to put out 10 amps. That's what this pump's putting out, a little over 10 amps. We go by the peak up here, right? Well, you can't really tell the amperage on AC voltage because if you look here, it's above and below, it's on the red scale. But what you can see is the armature good. And when we talk about the armature being good, I just so happen to have a fuel pump cut open here for you. Okay. This is the armature. Okay, this happens to be a 12 bar. So when you talk about bars, that's all of these things. By the way, this is no different than a starter motor we looked at for years, right? Here we have an 8-bar pump that's running in there. This is a 12-bar pump. This came out of a Nissan. Okay, and it was a bad pump. Now, this is very important to realize that once you go more than 1 amp difference from the peak, so let's say this peak right here was jumping up here. That'd be more than 1 box difference, right? Or one is dipping down more. When it's more than 1 box difference, that's where you got a problem with the pump. So it's not just good to know, oh, the amperage is 9 to 11 amps on a Vortex pump. You know, 4 amps on this particular Ford or whatever, okay? That's not good enough to know. What's important to know is, do we have a steady pattern? Because what happens to the armature, like the old starter motors, right?
Get a
Brushes would work.
You get a bad spot on one of the
Get a
bars.
bad spot.
Flat
And-
spot. Smack
spot.
with a hammer, the engine starts.
And by the way, isn't this very
Same
similar?
thing with the fuel pump. You can smack the tank, engine start, that's why.
And by the way, isn't this very similar to relative compression that we can test?
Certainly it
Sure.
is.
Okay, you want
So-
even humps. Very
Unlike
important.
the starter that won't start till you smack it, or the fuel pump that won't start the car until you hit bottom of the
tank.
tank, you can catch this before it's a no start.
That's
Or
the key.
between intermittent no start situations.
Right.
It's like looking at blood pressure. You may not have to be, in the emergency room yet. Your doctor can catch things going on with your ticker before you have a real problem.
Now, one thing I didn't put here, fuel trim, the E-scan is great for that because it has a box, a square box where we have, boxes at idle and low, and it has boxes that go all the way through for fuel trim. If we're
Yeah,
red up
I've
top,
used that tool. It
Okay.
is great.
when it's red up top, we got a fuel delivery problem, don't we?
Yeah, yeah.
We can confirm it, what we're doing here. See if the fuel pump is good or bad. So there's some neat stuff here that we can take a peek at. Now this is a good pump, and look at the pressure and amperage. Now remember, we're at 48 pounds, and how much, Dave? How much flow?
610 pattern, we got a bad pattern. Good pattern down here, lower right-hand corner. Looks a lot like that pump that G was showing you in his fuel injection simulator. Over here, though, that's a bad pump. Now, they come in many different shapes and sizes, but you see, it's not rhythmic. It's not like the plowed field. If you ever looked at an alternator's ripple voltage on a scope many years ago, I used to be an auto electric guy. We saw this right out of our AC voltage out of our alternators. We call it the plowed field look. That doesn't look like a plowed field. That looks like a mess. So when you see inconsistencies, when you see a bunch of the plowed field effect, and then we drop out or we jump up, you're seeing something that is repeated over and over. You're catching the onset of a bad pump. The car may run in the door. It may actually have decent trim, but if it's got an intermittent situation where the customer's complaining about a no start or poor drivability, backfires, lean, whatever, then we can catch that before the pump actually kicks the bucket, and now you're looking at the tow bill and the dissatisfied customer.
By the way, what you're looking at up there, you see the bad one? I took that years back in this very bay we're standing in. This was a bad Toyota, and when I hit the bottom, go to the bottom, you notice this is ground on a Fluke 98. This little thing right over here is the ground line. This pump was going up 100 millivolts equals 1 amp, so each dot, 1, 2, 3, 4, 5, just about 5.5 amps, went all the way down to ground. That was a bad pump compared to when I changed the pump, that was the good pump. Okay, so that was something that I did years back on a car in that very bay on a Toyota. Now let's take a look at the pump I hooked up. This is a different pump, and how many pounds of pressure did we have, Dave?
48.
48, so I'm going to give you 48 pounds, and how much flow did we have?
6/10 of a gallon.
6/10 plus of a gallon. So let's pop this on. Well, first of all, look at our pump, it's kind of choppy, and by the way, are we up at 48 yet?
No, we're 30.
Well, I'm going to bring you up to 48, because that's what you want. Where's our flow, Dave?
Oh wow! So you brought the flow up with your valve there.
I brought my pressure
And you
up.
brought the
This is-
flow up the pressure up to the right pressure. That flow dropped down to less than half.
Yep, because
It's
here's
like 2.5, 0.25 instead of 0.6 gallons.
2/10 of a gallon. Rule of thumb. Now, there's plenty of fuel calculators out there. I can give a rat's butt. I'm going to tell you this. 6-cylinder or 8-cylinder car, you need at least 5/10 of a gallon. You cannot do this by putting this in a bottle, a pint in 15
Yeah.
seconds. It's maybe one way around it, guys, but a flow gauge, believe me, I did a whole bunch of cars. You know, some like Pete had a good story, and I've done this in the past before owning a flow gauge. You run the vehicle, you have your fuel pressure hose with the little drain, you start putting fluid or gasoline out of it, the car starts to stumble, meaning it can't carry it enough to put that pint in 15 seconds out. Now, not all cars do that. Stuff I didn't put here because of time into the PowerPoint. I have vehicles that you would swear, current ramping, just about perfect. And when I mean just about perfect, you would never notice the difference. The flow was a difference between 3/10 of a gallon and 6/10 of a
Wow.
gallon. As soon as the pump was changed, it was over 6/10, 3/10, like this.
So the electrical signature isn't the whole story.
It's not the whole story.
You gotta see the
flow. Now watch, we can let flow, this is like electricity, right? Current is flow. Watch the flow. What happens to our pressure? Oh, you got all the flow you want. Okay. You got all the flow, now watch the pressure. As we add the correct pressure of 48, no funny
Pressure's coming
business.
up.
Look at our flow.
Goes way down.
So that's super important. And look at our amperage here. Look at what this pattern looks like.
Lower amperage, it's a crappy signal. And on the
Junky,
current, the
we
blue,
say.
the red, the voltage is even crappier.
Junky, we say. No, you can say that. It's all legit. But I'm just picking on poor Dave. Anyway, so that's some of the stuff here. We're going to move on to the car. And thank you very much, Dave, for all your help. I'm going to go annoy you now
Oh, thank you.
on
All
your
right.
stuff and turn this beeping. My brain is beeping.
Well, the first thing we're going to do, this is essentials, Foundation 101. If you suspect a fuel system problem, drivability, and we're going to induce drivability here on this car really quick. But this is a late model Ford 4-cylinder little Fusion. You're going to put a fuel pressure gauge on. And as G said earlier, you know, one way to cue you in to see if maybe you might want to do that is see what the current draw is on the injectors. The lower the pressure, if it's drastically low, that current draw is going to be low to go with it. So Alex put a fuel pressure gauge on here a little while ago, and what was that pressure? Was it 60?
60.
50?
60.
60. 60 pounds. And so we were good with that. Now, let's talk electrical on the car. We've seen some stuff over here in a box. You need to see how it works on a car, because that's the real world. So I popped open the fuse panel here, the bus electrical center with the relays and fuses, and sure enough, the owner's manual is not in the car. It tells you what fuse and what relay is what. So we had to look it up, all data. We did find a little bit. We found what relay is what, but we couldn't find what fuse was what quickly. We did find a little diode symbol on something. We'll talk about that.
Diodes, real important. Ford loves using them all over the place besides European cars. So now, right in the fuse box, for the fuel pump, you have a diode. Because this fuel pump has a fuel module, doesn't it?
Right.
So it looks at VSS, vehicle speed, Prindle, park reverse drive neutral, and it looks at VSS, vehicle speed.
Not uncommon these days.
And RPM.
Both on just regular common rail sequential port and the GDI, gas direct injection, for a fuel pump, oftentimes on the serial data bus, the CAN bus, talking to that ECM and giving a pulse width modulated signal to the fuel pump. So we never did find a fuel pump fuse. We just pulled the relay out. Now, you can buy a relay tester, you can buy a relay substitute tool, and it's very handy to have stuff like that. And you can do a little MacGyver work around it. You just pull that relay out.
Oh, you have it still in there.
And if you look at the relay, all relays are pretty much the same. It's a single pole, single throw relay. You've got the winding and you've got the contacts, and the contacts, one side will be hot all the time. The other side will be hot when the winding is energized by ground and the fuel pump output from the ECM, usually a high side driver.
So let's look at this one, Dave. We got 4 pins. This is a very simple
This
setup
is
here,
pretty
right?
much a garden variety relay. They almost all work the same. The contacts that you want to jumper are terminals 30 and 87, and it shows you a picture on the bottom, which one's 30 and 87, these two right here that are perpendicular from each other. One's turned this way and one's turned that way.
Think of a T.
Yeah, we're going to go ahead and just take some jumper wires, and I've got a couple of jumpers right here. They're going to fit in there. Then I'm going to connect a meter through there. If I wanted to do that, I could do that. It could go in series with the fuel pump. So we're not going to get anything fancy yet with the picoscope and all that. We'll do that, but we're going to do this first, just basic stuff. And if I want to go through there, what I need to do is I got a headless meter. Let's go get that meter head. And let's put it somewhere where we can really see it. Go ahead and turn it on to current.
Don't say it died.
Yeah. Maybe it'll hook back up when we go back in. This is the Fluke 233. Very handy tool. Do your connections at one spot and take the head with you under the dash.
Handy, but batteries.
Yeah. Want to get another meter here?
The real world.
Yeah.
Okay, so let's
Grab me another meter.
just
Give me your little auto tech there, the yellow one. Okay, go ahead and get that turned on to amps. That's important. This is where a lot of guys, you prefer an amp clamp because you're not having to do anything intrusive. But when you use the amp clamp, you got to do converting of the millivolts that the amp clamp puts out into current. That's the math you have to do in your head with the decimal point. But if you use a meter in series, it reads the actual current. You don't have to do any mathematics, but you got to remember where in the heck the leads go. So I've never used this meter before, but I see at the bottom it says 10 amp max fuse. So there's probably a special fuse in the back of this dude. And I'm going to put red where it says A for amps, 10 amp max fuse.
Yeah,
and
not
I'm
in the
gonna put
milliamp,
black.
Jack.
Yeah,
It's
not
not
the
a look.
milliamp, and not over here either for the volts or ohms. And over here is common. So if you just kind of bridge where it says amps, 10 amps, red there, and black common, now if I run the current between these two leads, what I show on the meter, you got to make sure you turn it to amps of DC if it differentiates between AC and DC, and some meters don't. Now I'm going to lay that there. And G's checking it because it's his meter. He doesn't want me to smoke it, right?
Well, we should really use a fuse.
I just happen to have a fuse over here.
And this is something you'd want to make up yourself, guys.
Just a little inline fuse here.
Or a jumper, a spade blade fuse or whatever.
So you don't blow the fuse in the meter. Some meters are unfused, you blow the meter, and that's expensive. So I'm going to go ahead and stick one end of this inline fuse into one of the jumpers. Now I'm going to go click on one of the two leads I have actually tied together, one alligator and one banana plug. I made this up myself just to be handy for different applications. And the other lead of the meter, G's putting into the other jumper wire, which completes that circuit. But how's it do it? Through the meter.
And there we go, 6
And
amps.
I can hear that meter run, that
You're gonna have to
fuel
hold
pump running.
You know when you're ready. And by the way, watch the amperage go high and go low.
You see it jump way up. Do that
6
again.
amps, and now it went real low.
Okay. Now hook it up again. 10. It went to about 10, and then to 6. That's that surge current. What did you call it? Rush-in current.
Rush in current and go right up immediately. Let's look at that again. Let's see if they can get on that meter real quick. Ready, gents?
Not quick enough.
And
Try
by
it
the way,
again.
we can hit min-max.
Yeah, let's do min-max. Now we're recording. We'll see if it was quick enough to catch it on a min-max.
Nope.
But I did catch it at 10 at one spot.
Okay,
At
we'll
one
try it
point I
again.
tried
Ready?
that.
Now, by the way, sometimes your meter is just not
Fast
quick
enough
enough,
for the
but
job.
that's where an amp clamp would come in handy.
But it is actually 30. What do you normally see for your rushing current when you've had a meter fast enough to catch it? And is it relevant to diagnostics?
Well,
that sudden surge when you first hook something up, almost like a voltage spike, in this case a current spike.
Right, and if you did this with an amp clamp on a lobscope, you may see that jump up. So sometimes it's quite high, sometimes 2 to 3 times higher
And
than
I thought I
normal.
saw 10 once, and I thought I saw 30 once. So
Very
anyways,
possible.
most techs are just looking at the continuous current. The inrush current, what is that telling me?
It did go OL, so it had to be over 10.
Okay. So that's telling me that's normal.
That's normal.
But you don't want it to go up and stay up. So anyways, let's go ahead and
Well, it's like when we push a car. There's a lot of energy first to
let's
go.
go ahead and pull the series ammeter out of this circuit. And now we'll connect the jumper wires up through the fuse without the meter. So now I'm going to just go right in here. So now I've just basically pulled the relay out. I went between 87 and 30, the contacts. I've jumpered the fuel pump. It's running. That's a test you might want to look at. Also look at the pressure at this time. You know, if you couldn't get pressure before, but you get it when you did that, guess what you just diagnosed? Real simple, a bad relay.
And make sure you get the right relays. There's a lot of relays out there. They may look similar, but they're absolutely wrong.
Close is not good enough?
Close is not
pressure
good
is,
enough.
huh? All right.
Exact one.
So now I'm going to use an amp clamp this time, so I don't have to go in series and worry about blowing my meter or whatever. Now I'm going to put the amp clamp into the meter, but this is going to be a voltage input, a millivolt input. So I put the red lead where I put normal leads for volts and ohms, and the black lead in common, and I'm going to switch it to millivolts. So that's going to be the MV with either the two solid lines for DC or the waiting line for AC. This one doesn't differentiate whether it's AC or DC, the same setting for both. I'm also going to zero the meter, put the first little point when I turn this 60 amp current clamp on. I'm not drawing 40 or 50 amps, so I want to turn it to the first setting, which is 1 millivolt equals 10 milliamps. So now, because it's a 1 to 10 ratio, millivolts versus amps, I just simply move the decimal point one notch, what I see on the meter, and that'll tell me what it is in real amps. Before I do that though, I'm going to hit the 0 button.
And by the way, guys, sometimes you won't get a complete zero.
Yeah, which I'm close. I'm getting kind of jumping around. Now I'm going to put it actually on the wire. Don't go, as G said earlier, don't go around a big old bunch of plastic conduit. Go right around the wire itself. And are we plugged in?
Yep, but remember this one you gotta take out for a second, then put in.
Yep, that's right. Let's go ahead and turn the key on. Watch your step. We got keys.
You gotta jump, so you should have.
This car, we found out, is a 2012, all kinds of little issues. We would jump the relay and it would shut off by itself, more to the circuit than we're aware of. Okay, so we are plugged in. Is that fuel pump running?
Nope. That's why we gotta shut it off for a second.
Okay, so the key was off. The key is on now, right? Let's start the engine up. There's the proof of the pudding. Is the fuel pump running?
Okay, watch fingers.
Okay, the fuel pump is running, and I've got .004 real world here, isn't it? So I have my meter on the wrong place. Just put the volt itself. I don't like that. Let's go get another meter.
It was on AC.
Is it on AC? Okay. Now what do we have?
DC, so.
Okay, we have about 8 amps.
Yep, keep switching.
Fluctuating, set on 8 amps, because it does have a fuel pump module. Does different pulse width modulation output to the actual pump itself.
So don't worry about the decimal point sometimes. So you got 8 amps
In
there.
this case, we don't, yeah.
Yep.
Let's try a different meter just for grants. You know what?
Right.
DC.
Okay, so we're just flipping over to a different meter here.
A little different reading.
That'd be 5 amps.
5 amps, 5.3 amps. Okay, now, you want to go beyond that, we can put the amp clamp into the picoscope like we saw earlier, do the same thing. You'll have the same readings, you'll see the fluctuations of the commutator as that fuel pump motor armature turns around. You can actually even conduct a little mathematical equation and determine how fast the fuel pump is running by counting the armature bars to see how many there are. Let's say an 8-bar armature, 12-bar armature like G mentioned, and then look at your seconds per division, your time base, and do a calculation of how fast is that fuel pump running. In fact, if it's a fuel pump module type of a vehicle like this is, that's good information to know if you can't get that PID. Now we notice we got a little bit of an issue here. As we pan over to the picoscope on our monitor, it almost looks like we got a problem. But again, do you have a drivability problem and a pattern problem? Do you have a drivability problem and a pressure problem?
And did you compare this to another known good?
Exactly.
This could be the signature of this pump module. Now normally, if they're all low and you get something like that, you have an armature problem. But it is repeatable pretty far down the road here. So I wouldn't know unless we got another 2012 vehicle or we did volume
Right.
and pressure and see what the normal pressure is. By the way, there's key on, engine off, and key on, engine running test on many vehicles for pressure. But flow is key.
Let's induce a problem and see what we got.
Okay, so let's watch this, and by the way, we are approximately about 5.5 amps. We're looking at the peak. Just a little over there, so I'd say about 5.5 amps. This is our fuel injector, by the way, here.
No one can hear you.
Alex, could I get you to man the ignition switch? Now, I'm going to take a resistance, similar to what you'd have with a bad connection, and I'm going to induce it in series with this little jumper circuit I just made to do my amp clamping and so forth.
So Dave, this was the voltage drop we were talking about, right?
Exactly, the voltage drop. So Alex already has this in his toolbox. He's got a little 1 ohm high wattage 10 watt resistor. Don't use a teeny tiny little resistor, you know, like in a package from Radio Shack. You'll smoke it real quick. But 10 watt will get warm. I'm going to connect it in series like it was a bad connection under the car somewhere with my jumpers. And I'm going to be looking at the amp clamp both on the picoscope and also here on my meter. And it's showing, what was it before, 5.6
Yep.
or something? Now it's 5.1. Let's see, is this starting to get warm here? Go ahead and start it up, Alex.
Now look at our amperage, how we cleaned everything up with some resistance. Look at the difference in the pattern.
So you're recommending putting resistors in series with fuel pump?
Hey, remember it's like that old article when you had a bad injector, throw some resistance across it.
Exactly. Now,
But that doesn't
pressure's
fix the
close-
problem.
Pressure's close to what it was, 54. But what's the current?
Our current is down to under 5 amps. And by the way, you can still see that pattern where one hump is up.
Let's shut it off. Let's add another resistor. So now I'm going to put another resistor in series with that resistor. So we'll have 2 ohms of resistance. Then I want to show you a picture and probably sign off here. We got 2 ohms resistance. Now let's start it up. What's our current draw on the Pico?
We need to start it up. Our amperage is only at about 3 amps there.
3 amps. What's the pressure?
Yeah, Alex? Oh, we almost had it.
Pressure is good. Volume is evidently low because it's not starting.
And watch the
And
dip.
that current draw.
Let's look at
Crank
the
it
screen.
again. Oh, it's trying to start.
Yep.
Nurse it. Get it running, will you?
Do it again.
Almost running. There we go. Lean. You're going to have a check engine light for a lean code. Maybe some misfire codes.
And
We got-
amperage is low.
Look at the pulse width.
Look at the pressure now.
The pulse width
with
is going up.
throbbing voltage robs current for the pump to work. And look at this pressure now. It's down around 36 or 37 psi. Now, how do I check that? That scenario that I bugged the car with, how do I check it? Let's look at our screen here, and we'll let you guys go spend time with your family this evening for watching us on the computer. So let's go ahead and get this up here so I can control it with my mouse. Make a very good point.
Which slide do you want?
I want to go up to where it has the fluke meter shown.
No one else can see it when I put it here.
There we go. Thank you.
Just click through.
Trying to. Here we go. Boom, 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 boom. Here we go. Now, voltage drop test. You're just checking the harness unplugged. That just checks open circuit voltage. If the pump won't run at all, you don't see voltage there. But when you're doing a voltage drop test on the power side, which we can actually do that in a second right here, across those resistances I induced into the system. If you've got a crummy connection here or anywhere between the engine compartment, the fuse panel, and the pump, the tank assembly, you're going to see a voltage drop between V plus positive up front and the actual pump feed itself. It ought to be less than 0.2 of a volt. If it's 5, 6 tenths of a volt, let's see what it is here. I'm going to go ahead and turn this meter from amps to volts, or from millivolts to volts, I should say. Get my amp clamp out of the way. Plug in. And I'm just going to go between this source of power right here and after the last resistor, which is right here. And the voltage drop across these resistors
Go to volts.
is 6 volts. That means how many volts do I have to the pump? The remaining 6. If I install 4 volts here, I've only got 8 volts to the pump. That's not enough. A lot of techs miss voltage drop tests when it comes to fuel pumps, and the pictures you see, one of the last pictures here in this display is a picture of, nope, let's see, go back up here. The telltale sign if you've got connection issues on your pump. Right. I thought I added that picture, but I didn't. But I'll just show you here on the actual pump. Here's the connections. If I pull one of these off, here's the pump connection right there, the gray and the black wire. What you want to do, whenever you replace a fuel pump, whether it's a hanger type or a modular assembly, you know, with the reservoir for fuel, whatever the case may be, I want you to look at the connections on both ends, not only on the pump itself, down in the assembly.
Of course, things come off hard.
I'll tell you what, let's go ahead and take it off this board. In fact, we've already robbed the fuel pump out of this Ford. We're working on the Ford, so it's appropriate. All right. If I get a tight shot right in here, you want to look
Light
for
off.
any
Light off. Take the light off, I can see it better.
Take the light off.
Yeah.
Okay. You want to look for any discoloration both on the connector and the terminal. There you go. And then you want to also look in the other side coming from the harness. You don't always see the discoloration on one side or the other, but look both sides. Look here, look down here. The least little bit of discoloration tells you it's gotten warm. Why did it get warm? You had a voltage drop. What the voltage drop do? Creates, the resistance creates a voltage drop which creates heat, like a toaster. When that heats up and then cools down, you turn the key off, we get expansion and contraction that causes the terminals to never fit. And so now you plug in the new unit, and maybe this side, the female terminals have expanded, and you got the same problem repeating over and over again. So you put a new pump in, and you say, well, whoever's pump it was, Delphi's or some other brand, you go, doggone it, they sold me a bad pump. Always check this first. You know, our reports from the field, our pumps have extremely high quality, all kinds of fuel. Even the E10, E15 has been proposed lately with 15% alcohol right at the pump. We're not talking about gasohol, I'm sorry, E85, we're talking about regular gasoline. Our pumps will run in that. So we got good quality pumps, but sometimes connection issues occur, and if you don't catch it, you'll keep throwing pumps at it every 6 months or so.
Weather packs.
Exactly.
Now, let's say when you take this off, one of the things you should get is new rubbers and new locking rings. One of the things that kills pumps, you have a slide there on, is dirt that grinds the pump up, fine silt. This thing that I have for years, you don't want to try a regular vacuum unless you want to go ba-boom, you don't like yourself one day. You're going to use air. This is an air vacuum. You simply connect your shop air, you suck the dirt. Rather than blowing it and blowing hydrocarbon vapors and blowing it in, you suck it. You do this before the lock and ring.
This is a lot like that choke tester. It makes a venturi. Shop air
Correct.
causes the air to go this way, creating a vacuum that way. Catch it in the bag, clean the crap up so it doesn't get in the tank and cause contamination problems for a comeback later.
Snap-on and Mac both sell that. Now, one last thing we want to do is voltage and amperage on the injector. So when you do amperage, You go to either one of the two wires. We have the shielding pulled back. Make sure your amp clamp is closed. And when you connect to the injector, you always connect one set of the lead to the negative side, meaning the computer is pulling that part of the injector down. Now, if you look at amperage over here, you're going to notice as voltage falls, amperage goes up. But let me change this amperage scale. A little tough with gloves on. I need to take these gloves off here. And we'll just make this a little bit nicer. And I'll overlay it with the 2-volt scale there.
Yeah.
We could see pronounced pintle hump right here.
The red is the voltage, 12 volts, turns on to ground, turns off, makes the inductive spike. Voltage is red. Channel B is red, that's voltage. Channel A is our current. And G, what's this you just said?
That is the pintle bump right there at a little bit more, about 60% of the total amperage.
So that's when that little solenoid pintle pulls up and then hits the seat and the fuel flows at that point right there. That's normal looking.
Yes, and that is approximately 1 amp. You'll pull about 900 milliamps. The scaling here is not correct, but it would pull approximately about 900 milliamps for 1 amp. Now, that's common. Remember, we were 700 and something milliamps with no fuel pressure.
Right.
So when I always do this, I show people with fuel pressure, without it. Check it out.
3/4 an amp versus.
Right. Almost an amp.
Yeah.
Just about an amp.
Right, right. Because we're on the 2.
Yeah, we're under 2 volts.
Double that, so, okay, so about an amp then.
Let's do this.
We went to 1 volt equals 1 amp. There we go.
Yeah, you know what? It's still, didn't convert it to amp, you don't want the amp. Says it, but didn't do it. But this is approximately 1 amp, and the lower you go with the voltage, it's a conversion, the higher the amperage is. So
It's not on all the time, so we're going to see the average current.
Right.
We've done a lot tonight. We've looked at fuel pressure, fuel current on the pump, on the injectors,
how to
pedal
test
pumps,
injectors, bumps,
changing
voltage drops.
the screens inside of an injector. A lot of techs may not
There's a
know you
lot
can
more
do
to
that.
know, obviously. You know, Motor Age and TST, and thanks to our sponsor Delphi, are able to bring you this at no cost to you, and it's educational. You can review this as many times you like. If you have questions, please email myself or Pete, and we'll make sure, and Dave will annoy Dave.
Yeah.
We'll get back to you with any questions that you do have. Upcoming stuff that we have coming up. Tomorrow night is the TST Roundtable. What is the TST Roundtable? The TST Roundtable is all about you guys. Meaning whatever on your mind, whether it be equipment, an issue on a vehicle or whatever. I know we got our buddy Alan coming on from New Orleans. He had a good question. Hopefully he brings that up tomorrow on the roundtable. And we'll see if a bunch of technicians can help figure it out. Again, no cost to you. Some other stuff coming up there.
Position sensors.
Position sensors. All sensors on a vehicle with Jim. He works for Wells Ignition. Another technician roundtable. It looks like I got to work near Christmas. The 22nd. Boy, oh boy, I never get time off. Our buddy John Anello doing module diagnostics. He'll be binging around. These, the December, the January big ones there, the roundtable's always free. The other ones are for a fee. And my buddy Wayne Colonna coming up. Wayne's a great guy there down in Florida, enjoying the sun, I bet. Transmission diagnostics for regular shops. One thing has hand in hand. And then our buddy here, Pete, with Motor Age, is doing Timken's bearings, right?
Yep.
So don't forget the bearings, boy. What you don't know about bearings, pretty scary. So tune in for all of these neat things. I don't know if we have anything else up there. Another Motor Age plug.
There's a Christmas sale, TST DVDs and meters.
Okay. Don't forget TST. We're a 501c3, and we appreciate
Non-profit.
we appreciate Motor Age working with us. We definitely appreciate Delphi. And to you and your family, I'd like to wish you, at least from TST and all of us here in New York, a very, very happy Thanksgiving and happy holidays to all.
Huh.
Oh, look at that.
God bless you
Yeah,
guys for taking
God
your
bless
time
you
out
guys.
tonight.
Your time
Enjoy
is
the
the
rest of your
most
evening.
important thing.
Yeah.
So thank you once again.
Thanks for coming.